When the mantle gets very shallow, it melts. When it melts, it makes basalt. So we have basalt. We start the conveyor belt. That's part of what's driving plate tectonics, is that making new basalt continuously is what they call ridge push. Not only is it up higher than the surrounding area, so that gravity is helping move the slabs off, but we're also making new material continuously. So the greatest volcanic activity on Earth is the continuous formation of basalts underwater at these ridges continuously for the last at least 4 billion years we've been doing that. And that's part of the fact that we're saying that we're not creating or destroying anything, we're reshuffling, right? So we're moving stuff around. We melt the mantle because of decompression, right? And then we have, it cools, and we have crust, and then it comes back down and melts again, right? So the energy that it takes to melt, which is an endothermic reaction, we have to put energy in there. However, the opposite is the exothermic reaction, is when they come to the other end, they release a lot of that energy. So that we're transferring energy around, right? We have that original thermal energy, but then we're moving it around and we're switching between phases. Okay, so now, the two biggest thermal effects on Earth are this really hot core and this cooling mantle. And so that there's a geothermal gradient as we go down. So that the places that we see heat coming out of the planet are where plumes arise, at mid-ocean ridges, and at the volcanic arcs, where the magmas are coming out. And so this is an interesting interplay between formation of crust, destruction of crust, building continents via that arc magmatism. When I say arc magmatism, I mean above the subduction zone, where the water comes out into the mantle, flux is melting, then that rises up. So that we get chains of them, and they're shaped like an arc because we're on a spherical planet. And so the slab isn't like we draw it. We draw the slab going down like this, but it's not, because we're on a planet, we're on a sphere. So it's going down like that, which means that it's an arcuate shape of the volcanoes that it makes. So if you look at the Japan arc, it's shaped like that. And all the arcs on Earth are shaped like that. And the magma that forms from the dehydration of the slab, causing mantle melting, it doesn't know what's above it. So it can rise up and come up like Japan in the ocean and make an oceanic arc, or it can be like the Andes and come up through continental crust and actually help make a big mountain range. Right? So we find the mountain ranges at the boundaries of the plates. And so either if it's ocean-ocean, or if it's continent-continent, that's where we make the mountain ranges. So the mountain ranges are important in this whole process of reshuffling things around and moving them around.